Welcome to Chapter 1 Quest Review, Part 1. This is in 3 parts just because the files are too big. Anyway, the great thing about this is that you can go forward or back, work on the problems that you're having trouble with. The ones that are easy for you, you can skip. Okay, so let's get started. Okay, number 1. Identify the number as prime, composite, or neither. So first we need to know something about prime numbers. Prime numbers have only one in itself as factors. So, for instance, 2 is a prime number because it only has one in itself. I know it's an even number. All the other even numbers that are higher than 2 are composites, but 2 is a prime number. 3, prime number, only one in itself are factors. Oh, and what are factors? Well, factors are like, say, 2 times 3 equals 6. The 2 and the 3 are factors. 6 is the product. So any two numbers multiplied times each other, or a number and a variable or whatever, they're all factors. Okay, so 2 has only one in itself. 3 has only one in itself. 4 has one in itself, but it also has 2. So 4 is not a prime number. How about 5? Well, yeah, 5 is a prime number. 1 in itself is the only ones. 6, nope, that's an even number above 2. Has 2 as a factor, has 3 as a factor. 7, that's a prime number, 1 in itself. 8, nope. 9, nope, it's 3. 10, nope. 11, yes. 12, no, but 13, yes. 14, no. 14, no. 15, no, because 3 and 5 and 1 in itself. 16, no. 17, yes. 18, no. 19, yes. 20, no. 21, no. 3, 7. 22, no. 23, yes. 24, nope. 25, nope. 26, no. 27, no. 28, no. 29, yes. I think you get the picture. So you're wondering about, what about 0? Well, the prime numbers are all natural numbers, and 0 is not a natural number. The natural numbers start with 1, 2, 3, and so on. They're the counting numbers. And 0 is a whole number. 0, 1, 2, 3. Also, it doesn't have factors, 1 in itself. How about 1? Well, no, 1, because 1 is itself, so that doesn't count either. This brings us back to the first problem. 1. Is it a prime, a composite, or neither? Well, it's neither. Oops. Neither. 91. Is 91 a prime, composite, or neither? Well, if something will divide into 91, it's, besides 1 in itself, it's a composite. So let's find out. We have to try some numbers. 2 won't divide into it because it's not even. 2 will only divide into even numbers. 3. What about 3? Let's try it. 3 into 91. 3 times 3 is 9. Bring down the 1. Nope. No, it's not. How about 4? No. 5? No, because it doesn't end in 5 or 0. 6? Of course not. 7? Let's try 7. Let's just get rid of this guy. Okay. 7. 1 times 2. 21. Yeah. 7 into 21 is 3. So it has factors. 7 times 13 equals 91. 91 is a composite. Now, what about 47? What are we going to do about 47? Let's try 2. No, it's odd. 3, maybe 3 into 47. 1, 17. 3 won't go into 17. 4 won't go. 5 won't go because it doesn't end in 5 and 0. 6 won't go. 7 won't go because 7 goes into 49, right? 8 won't go. 9 won't go because we know the times tables. It doesn't work 9. 10 won't go. 11 won't go because all the 11s, all the way up to 100, go 11, 22, 33, 44, 55. 12 won't go. 13, no? 3 times 13 is 39. 4 times 13. See, it ends in an even number, forget it. So, 14, no. 15, no, because 15 goes into 45. 16, no. 17. How about 17? 17 into 47 goes about 2 times. 34. 3. 13, no. 17 won't go. So, it's obviously a prime. There we have it. Number 4. Write the number as a product of prime numbers. Well, to do that, we need to find out all the prime numbers that are in there, all the prime factors that are part of it. And the way to do that is with a factor tree. So let's make a factor tree here. Since it ends in 5, I know that 5 will divide into it, so I'm going to just try 5. Do this over on the side. 5 into 175 goes 3, 5 and 25, okay, 35. So, 5 times 35. Now I'm done with the 5 because that's a prime number. 35, though, that's made up of 5 and 7. Alright, there I have all the prime numbers. So I'll write this, 175, see, 5 times 5 times 7, see? So 5 times 5 times 7. Later on when we do exponents, we'll see that we'll write it in this way. Exponents are like kind of a shortcut. So 5 to the second power, which is 5 times 5 times 7. There you have it. Number 5, evaluate the expression for the given value of x. Okay, we have 18 over x minus 3. Now that fraction bar also means divide. So, and it's separated into 2 groups. There's the 18 on top and the x minus 3 on the bottom. Alright, what we do with this is we stick in the value for x. It's quite simple. It may look hard, but it's quite an easy thing. Easy process. So we just stick the 21 in for x. So we've got 18 divided by 21 minus 3, which equals 18 divided by 18, which is 1. Number 6, translate the phrase to an algebraic expression. The difference between 11 times a number and 3. Alright, when we see something like that, we've got to translate it from words into algebraic symbols. Okay, the difference, you know, that's a subtraction. And it's going to be between 2 things. The first thing that we come to is 11 times a number. That's going to come first. There, that's better. I got it all in one line. Okay, the difference between 11 times a number and 3. So 11 times a number would be 11x. And 3. Excuse me. See, I'm really here. There we are. So it's the difference between 11 times a number and 3. But since 11 times a number, which is 11x, a number is x, comes first, we put that first, and then we put minus 3. See, if it said the sum or the quotient or the product, we would always put the 11 times first. We would put the first thing that comes in that sentence first in the equation or in the expression. Number 7. Uh-oh, it's a word problem. Can we do these? Of course. All right, the dimensions of a rectangular yard are 40 feet wide, W, by 100 feet long, L. The perimeter P of the yard can be found by adding all the sides together. Write an equation that expresses the perimeter. What is its perimeter? Okay, so it's asking us to write an algebraic equation or a formula. It's asking us to put together a formula, which is basically algebra, and it tells us everything, which is great. It tells us that W is going to be for the width, L is going to be for the length, P is the perimeter. It tells us what you have to do to get the perimeter. And it also tells us it's a rectangle. And so that's all the information we need. You have to keep track of all the information. You know, pay attention. You could underline the important pieces of information. You know, like 40 feet wide. Let's use red. 40 feet wide. And it's 104 feet long. And W is the symbol for width, and L is for length. Perimeter P. P is for perimeter. And it can be found by adding up all the sides. So perimeter equals the sum of all the sides. Okay, so first thing it's telling us to do is write an equation. Okay, so we'll do that. We'll say, all right, now I'm going back to black. P equals, well, a rectangle, the length, the width, the width. The lengths, and well, my picture isn't perfect, but the lengths are equal to each other, and the widths are equal to each other. The perimeter, which is all the way around, would be adding all those up. So you have, let's say you have L plus W plus L plus W, which would be okay, but we could kind of simplify that and make it P equals 2 L's plus 2 W's. All right, now it says, well, what is the perimeter? All right, so you see, the trouble with word problems is not that they're super hard. They are harder than other things because we have to figure out what the other person meant. But it's that we panic. That's the problem. We think, oh God, I can't do a word problem. All right, so the length is 104 and the width is 40. So we'll stick in, just like we did for the evaluation problem where we stuck something in for X, now we're just sticking in something for L and for W, and we're looking for the P. Alright, the L is 104, so 2 times 104. Remember, when you put something in parentheses like that with a number right next to it, that's times. And then plus 2 times the width, which is 40. Okay, and that's going to equal our P. So 2 times 104, which you could figure out on the side or in your head, is 208. Plus 2 times 40 is 80. And we add those together, and we get 288 is our perimeter. Number 8. A whole number can either be a natural number or the number what? Okay, so we have to remember what natural numbers are. Natural numbers are 1, 2, 3, 4, ... You know, they go on and on up to infinity. They're all the counting numbers, something we've been using since we were little kids. Okay, the whole numbers, there's only one thing in addition there, and that is 0. 0, 1, 2, 3, 4, and so on. So the number that's missing here is 0. Number 9, what sets of numbers does 0 belong to? Well, for that we need to know what the sets of numbers are, or the different names for the groups of numbers we've talked about. We know about the natural numbers and the whole numbers. What other groups are there? So I'm going to draw you a picture. Okay, let's say that we'll call these all real numbers that are inside this box, let's say. This is a set of all real numbers. That's a group, you know, a collection. Okay, so real numbers. All real numbers. Real numbers are made up of the rational numbers, the irrational. Irrational numbers. It's large sets of numbers. But let's start with the ones we've already heard about. Okay, so remember we know the natural numbers. Those are these. I'm just going to abbreviate that. The 1, 2, 3, ... So it's the natural numbers, and then the whole numbers include the natural numbers plus 0. So 0, 1, 2, 3, ... And those are whole numbers. Then there's another large group of numbers that are like the whole numbers and the natural numbers, and they're the integers. The integers contain the natural numbers and the whole numbers, and all the negative numbers. All the negative, say if all the natural numbers were negative. So we could write that as ... 3, 2, 1. These are negatives. Then 0. Get 0 in there. And then 1, 2, 3, ... Those are the integers. So the rational numbers, those are the ones in between them. You know, if we had a number line here, and we had 0 in the middle, and we would have 1, 2, 3, 4, and we'd have -1, -2, -3, -4, going on in both directions to infinity, to positive and negative infinity. The numbers that were in between, like between 1 and 2, or between 0 and 1, or between 0 and -1, between -1 and -2, and so on, all those numbers in between that aren't irrational numbers are called the rational numbers. So all the fractions, for instance, like 2/3, 1/4, or the decimals, 0.093, or we could even have parts like 1 and 2/3, you know, a mix of a whole number and a fraction, which they call a mixed number. But it's basically a fraction, right? Or a decimal, like 5.73. Those are all rational numbers. And the reason they're called rational numbers is they can be made, every rational number can be turned into a fraction of two integers. Okay, so it could be positive or negative, and it could be made from a fraction of two integers, like, you know, 2/5. The number 3 can be put over 1, and say the number -7, you can put that over 1, -7 over 1. You can see you can make a fraction out of that. Any decimal you can turn into a fraction, like 2.78. We could turn that into 2 78 hundredths. And of course we can reduce that, but I'm not going to do that right now. Okay, so those are the rational numbers. Rational meaning not sane, but you can make a ratio out of them, or a fraction. A fraction is a ratio, this to that. Okay, now irrational numbers then are numbers you can't do that with. And so the ones that are like that are pi, square root of 2. For instance, square root of 16, well, that equals 4. See, so that's not an irrational number. That would go over there in the rational numbers. That's actually a natural number, a whole number, an integer, and a rational number. See, so there's numbers that belong to all these different classes because some are bigger than others. And all of these numbers we're talking about here, they all belong to the real numbers. So rational numbers, you could figure them out, like pi is 3.14 approximately. You can get it even better, 3.14159, and you can keep on going into the millions of decimal places. The thing about the irrational numbers is this decimal part will never repeat. There'll never be a pattern. Rational numbers will always repeat. So you're gonna, if you have a decimal, for instance, irrational number, by the way, you can make a decimal out of. You can make a decimal out of them, but they never repeat. So it's always not exactly the answer, right? But rational numbers will be exactly the answer, can be exactly the answer, I should say, unless we're rounding them, say. So I hope I'm not confusing you here. But okay, so a rational number, if we divide any fraction, like 2/3 or 1/8, we divide the denominator into the numerator, we'll get a decimal. If we divide 3 into 2, we're going to get 0.6, and then we're going to get another 6, and I'm going to talk about this again later. 6, 6, 6, 6, and the way, well, that's supposed to be a 6, and the way we write this is, we write it as 0.6 with a line over it. That means that 6 repeats. 1/8 will turn into 0.125. So that's a terminating decimal, and that doesn't repeat. But see, these are rational numbers. Both of these are rational numbers because we can make it either a repeating decimal out of them, something that has a pattern, or we make it a terminating decimal. Okay, but an irrational number you can't do that with. So we can figure out square roots, for instance, by just hunting for the number. We try, well, what number can we multiply by itself will give us 2? Will 1.2 do it? 2 times 2 is 4, times 1 is 2, 12, 4, 4, 1. 2 places. So 1.44. So it's not 1.2, it's bigger than that. Maybe it's like 1.4. And so we can just keep making it getting closer and closer and closer, and we'll get larger and larger decimals. But we'll never get a repeating pattern. And then real numbers include all those. That's what real numbers are. Those numbers all together. Alright, so what sets of numbers does 0 belong to? Well, 0 is not a natural number, but it is it's a whole number. It's an integer. It's a rational number. And it's a real number. The only kind it's not are the ones we're talking about here. It's not an irrational number. What sets of numbers, number 10, what sets of numbers does 2/3 belong to? 2/3. Okay. Alright, well, let's look back at this thing. Doesn't belong to the natural numbers, those are the counting numbers. Doesn't belong to the whole numbers. Doesn't belong to the integers. It's because it's between the integers, right? So it's a rational number. We talked about the decimals and the fractions. It's not an irrational number, and it is a real number, because all the numbers we'll be dealing with will be real numbers. So, not so hard. Number 11, write in exponential notation. That means write with exponents or powers. 9 times 9 times 9. Well, remember the exponents, we have a base, in this case it's 9, and then we have an exponent, which goes up here, a small number. And that small number tells us how many times the base is multiplied times itself. So in this case it's 3 times, so it would be, the answer would be 9 to the 3rd power. Number 12, 2/3 to the 3rd power. Okay, so now, in this case, 2/3 is our base, and the 3 is our exponent. The 3 is telling us that the base is multiplied times itself 3 times. So what we have then is we have 2/3 times 2/3 times 2/3. Okay, so fractions, we multiply the numerators times the numerators, and denominators times the denominators. Now we could do 2 at a time here. Doesn't mean you have to do all 3 at once if you don't want to. So we could do 2/3 times 2/3, and we get 4/9. And then we have another 2/3 to multiply by. That would give us 8/27. Or if you did it in your head, it would be 2 times 2 times 2 equals 8. And 3 times 3 times 3 equals 27. That's the answer. 13. 5 to the third power. Okay, so now we know what to do with this. It's 5 times 5 times 5. And, I didn't mention it, but back in number 11, it said to only write it in exponential notation. It didn't say to solve it, so we just put 9 to the third power and left it at that. But here they want us to solve it. So you can do 2 at a time. Go 5 times 5 equals 25, and then multiply that times 5. And you could do that on the side if you want. I'm not doing it on the side, am I? 5 times 5 is 25, 5 times 2 is 10, 12, 125 equals 125. That's the answer. 18. Okay, this is find the value of the expression. Okay, so we have a whole bunch of numbers multiplied and some divided by each other, and we have a distribution situation here too. So, two things. One is order of operations, which is, remember, PEMDAS. In parentheses stands for more than just parentheses. It's anything that groups. So we have parentheses, we have brackets. In this situation we don't have any brackets. But we do have a fraction bar with a bunch of numbers on the top and a bunch of numbers on the bottom. Right? So that's a grouping. That groups the top of this with the bottom of this. Another grouping symbol would be the absolute value, like the absolute value of -5. You know, the absolute value. Sometimes you'll see absolute value of -5 times 7. You know, or you'll see some other numbers inside there. So that's a grouping thing. You solve what's inside there first. Then you do what the absolute value tells you to do. So any grouping symbols, that's what the P is. So I divide that up. That's the first thing you do. And the next thing is exponents, which we just talked about. You do your exponents next. And then the next thing is multiplication or division, whichever comes first, from left to right. And everything you do it from left to right. As you do a few hundred of these, you start realizing there are some shortcuts you can take. But don't take shortcuts before you're sure of them. It's not going to save you time, you're just going to get the problems wrong. Okay, so if division comes first here, you do division first. If multiplication comes first, you do multiplication first. And then the last part is addition or subtraction, whichever comes first. If subtraction comes first, you do that first. If addition comes first, you do that first. Okay, so we're going to start with our P. Now we have two parentheses, but, so we can solve those first. Both parentheses are 6 minus 5. So let's do both of them. So we just recopy this thing and just solve one little piece at a time. See, if you try to do the whole thing at once, of course you're going to get it wrong. If you do one little piece, each little piece is usually simple. And as long as you copy everything down, which doesn't take long, you think, oh, it's going to take too long. Not really. Okay, so we've got 8. We'll solve this. 6 minus 5 is 1. And there's plus 8 times 3. And that's over this is 8 times 6 over minus 1, which is 1. Okay, so now we can solve that. 8 times 1 is 8. So now we have 8, I better start writing smaller, plus 8 times 3. And that's over 8. Okay, so the bottom part of our grouping thing is done. Now we're going to look at this top. There's 8 plus 8 times 3. So what do we do first? We don't add the 8 to the 8. We'll get a different answer. That's why we do follow a certain order, so we can get the same answer all the time. We do the multiplication first. That comes first in our PEMDAS thing. So 8 times 3 is 24. So we have 8 plus 24 now, and that's over 8. 8 plus 24 is 32. Now that's divided by 8. Notice we did one step. Even though I could do some things ahead or at the same time, I'm only doing the really obvious things at the same time. Okay, now 32 divided by 8 is 4. And we have an answer. Number 15. 6 to the third power divided by 12 minus 10. Again, order of operations. Order of operations, I mean, we're always going to be using order of operations. We're going to be using it when we are working with variables. You know, when we're solving equations, we're going to always use the order of operations. We may be simplifying two sides of an equation. So we're always going to be using this. So you want to get used to it and get it right each time. Okay. So, what comes first? Are there any parentheses? No, there's no parentheses. So there is an exponent though. So we'll do the exponent first. 6 to the third power is, we'll just do this on the side, 6 times 6 times 6. So 6 times 6 is 36 times 6. 6 times 3 is 18, plus 3 is 21. Okay, so $216 divided by 12 minus 10. Okay, again, let's do this division problem. Division comes before subtraction, so we're going to divide 12 into 216. 12 goes into 21 once. 9, okay. You know, you do what you need to do. 12 into 96 is 8. Okay, so it's 18. So this is 18 minus 10. 18 minus 10 is 8. That's our answer. Okay, number 16. We have 4 times this bracket grouping of 7 plus 8 times 3 to the second power. So the first thing we do is we look at our parentheses, right? Well, there's one big parenthesis. Inside that there's a parenthesis. And inside that, inside parenthesis. So we go to the inside of the inside first. See, because we look at the first group, the larger group, and we look for groups inside the group. So whatever the innermost group is, that's what we do first. In this case, it's 3 to the second power. So 3 to the second power means 3 times 3 is 9. So we just copy everything down for our brackets back in 7 plus 8 times, and then 3 to the second power is 9. Our brackets back. Okay, so now look inside the parentheses again. We're still at the parentheses level, or our brackets. And what do we do first? Well, we don't add first. We always multiply before we add, right? So 8 times 9, that's 72. The answer for that, we keep our brackets. That's plus 7. And then times 4. So we still go inside the parentheses. 7 plus 72 is 79. That is times 4. So we'll do that on the side, 79 times 4. This is the only place I'll use that X symbol for times. Okay, 4 times 9 is 36. But you don't have to use it there either. 4 times 7 is 28, 9, 30, 31. 316. So the answer is 316.